everyone, welcome to Exam B. So in this video we are going to discuss another question from the previous year paper of Indian Economic Services examination. This is the question from General Economics paper 1, and this is the part 3 in this series of previous year question discussion. For previous parts, you can find the link in the description of this video where we bring questions from the previous year paper and discuss it here in detail. So let's start for the video. So before starting and discussing the question, I would like to tell you that all the past year questions from 2010 to 2022, these have been segregated topic wise for the Indian Economic Service examination for all the 4 papers, and against each and every question you will also find the marks for the respective question and in which year they appeared. So all of this analysis we have done for you. You can find the link of that PDF in the description of this video. You can download it from there. And we also have an IES Test Series. If you want to streamline your preparation, you can do that too. So you can have a look at the test series that we provide. This is the test series schedule. We started it from 17th of March. You can download the schedule also from the description of this video. If you wish you to enroll, you can still enroll in between and write the tests, and we will give you feedback on them and provide sample answers also. Also, if you are writing the Indian Economic Service exam, then you must be also writing for the RBI Grade B DAPR. If not, then you should definitely write it and check out the course that we have. That is also going to help you a lot in your preparation. Now let's start the video. So this question says that explain the concept of direct regression and reverse regression in presence of 2 variables x and y. This was a 5-marker question which appeared in General Economics paper 1 in the previous year. So how do you approach such kind of questions? So you have to tell that what is exactly direct regression and reverse regression. So before telling that, let's understand what is regression. So one particular meaning of regression is that you move in a backward direction. Basically, you have certain data, and then through that data you generate the model. Ideally, it should be that the model is generating a data for you. That should be the ideal case. But in regression, however, you have data in hand, and through this data you generate the model. For instance, let's say you have data on consumption and income. Now you want to do an analysis that whether consumption depends upon income or your income depends upon consumption levels. So you run a regression accordingly by keeping one of the variables to be independent variable and the other to be dependent variable to have meaningful inferences about this data that you have. So this is one particular form of simple linear regression model here. Xi's are the independent variables, mu I is your error terms, that is, it tells you the difference between the observed value of the variable and the point on the fitted line. So the difference that you get from the point on the fitted line to the observed value, this is your error, which is represented by mu I, and yi is your dependent variable, and beta naught and beta 1 are the parameters of the model. So this is what you have to estimate. Okay, this you do not know for the population, so you collect data and you estimate this beta naught and beta 1. Now the famous technique that is used is the ordinary least square technique. In this technique, you minimize the sum of squares of the error term. Why do you take squares? Because if you do not square the errors, the positive and the negative error terms will cancel each other out. Okay, that's why you square the errors and then you minimize this. Doing this gives you the values, the estimates for your population parameter beta naught and beta 1 hat. This is what you get when you minimize this. So these estimates are actually best linear unbiased estimates that you get by minimizing the sum of squares of the error terms. These are blue. Okay, this is coming from the Gauss-Markov theorem itself, that among the class of all linear unbiased estimators, these will have the minimum variance, that it is, these will be blue. Okay, best linear unbiased estimates that you get while minimizing the sum of squares of the error terms. Now there are two ways that this can be done. Okay, one is that if you take the vertical difference, okay, look at this diagram here. If you are taking the vertical difference from your observed point to the fitted line, okay, this vertical distance, then you are doing a direct regression. Okay, but on the other hand, if you are taking the horizontal difference from the observed point to the fitted line, this horizontal difference, if you are taking to minimize the sum of squares of the error terms, then you are doing a reverse or inverse regression. Okay, so I hope the distinction between the two is now clear. You can pause the video and read everything here that is written, and also here. So this much point is enough. You can also draw the diagram. Drawing diagram is very important in your IES examination, because this can fetch you really good marks if you also have drawn diagram. So whenever there is a question which requires diagram, you must draw it. All right. Okay, I hope you have understood this question. For more such videos where we solve the previous year questions, you can subscribe to the channel and press the bell icon. Also, if you have any queries regarding the exam, call up on this number and we will solve it, or you can also drop us an email. Thank you.